Hello friends, in this tutorial I am going to show you how to create layout by using Cadence SOC encounter, and for that the synthesized code is generated by using Cadence RTL compiler tool. In this example I am going to consider floating point multiplication process. Here I have taken a general code for or open source code for this a floating point multiplier, and you can see that this particular code is having a number of submodules that are FP normalize, FP round, FP pack, FP unpack, okay, and FP round. So that are all the submodules available. Okay, so that particular modules I have placed here. These are the five codes or five files, VHDL files, which is going to uh, synthesize by using Cadence RTL compiler. To perform RTL, this one synopsis to perform the synthesis process by using a Cadence RTL compiler, we should use a TCL file. Okay, so this is the TCL file which is used for synthesized code generation. Okay, here I have used Cadence 180 nanometer library. Okay, that is OSU SOC 2.7. So this is the library search path, and from this particular path I am going to access this particular library file, and I have provided some basic information which is needed for synthesizing process. So here I have mentioned the top level top module name. Okay, that is represented as fpmul. So in the code this is the top module, and this is the top module name fpmul. Okay, and we have mentioned the clock frequency and minimum delay for clock, maximum delay for input delay for clock, output delay for clock. Okay, and run name, that is you can decide your own name. Okay, you can give your own name, and we are going to read the HDL files here, and these are all the files which is needed for this floating point multiplication process. And we are going to elaborate the design, and we are going to give the clock and input and output delay. And here we are going to checking the design and synthesizing the code and generating the mapped code. And for that we are going to generate some reports, okay, to understand the characteristics of this particular code or this project. We need this particular reports, so that timing and area power reports, and generating or writing the synthesized Verilog code and SDC file. Okay, so these are the necessary information which should be provided this inside of this TCL file. So now we are going to open the RTL compiler. So you can open a terminal, and you can give the command rc hyphen space hyphen GUI. You can open the source or you can source the script here by selecting this particular TCL file. Okay, so now it's that particular TCL code is taken and it is executing the commands. So you can see the output here. Now the code is compiled and you can see the synthesized view. So you can double click on this top module, okay, and you can see the synthesized view, and also you can see the internal modules. Okay, you can double click on that particular modules and you can see the gate level schematic. Now you can see the HDL code, or we have used VHDL code, so you can see the corresponding code. So this is the top level code which is used for floating point multiplication. And here along with this you can find out the some other parameters like area, and power, and this one delay, worst path delay. Okay, so this one you can get from this particular software. And previously we have mentioned in the TCL file for to report this timing and area, power. So those informations also present here. You can see that. See here. So this is the area report. Okay, you can see the area, total area, how much, and you can get power, total power for the top level instance. So how much the power it will consume in nanowatts, and also for the timing report. Okay, so this is the timing. Finally you can get the slack, timing slack. Okay, and further we have generated this SDC, so that also you can visualize. is DC. Okay, and this information you can get from this one Cadence RTL compiler, and you can the main objective is to generate the structural Verilog code that is instantiated with the standard cell libraries. You can see here. So this is the entire top module, okay, integrated in a single file. You can see this is the standard cell library. This is implemented, or this is instantiated with the standard cell libraries. Okay, see. So now we are going to generate the layout from this particular Verilog file. So I will show you that how to create a layout in SOC encounter.